Hi everybody, I'm here Prasad. Now I'm going to explain, see the title of the diagram, flowchart with the cursor, flowchart for multiplication operation. This can be asked as flowchart for multiplication algorithm, both are same. Multiplication means into symbol. See, this is the topic from computer arithmetics. From the above, with a cursor I will explain you with marker, computer arithmetics. And I will zoom it and show you. Arithmetic means mathematical calculation, addition, see the cursor, subtraction, multiplication, division and modulo symbol. This is very important and tough topic. I missed this video and one more video I have shooted, addition and subtraction algorithm, that also I will show you and I will put the end of the card. Watch till the end. I will put the playlist also and I will explain this topic very simply and clearly. Watch till the end. This is very important question. You may get this question compulsory. This is a topic from third unit. Third unit, computer organization and architecture. See the cursor. And this question may be asked something like this. See here, this is the previous question paper question. And I will show you with the marker. Part B. Part B, multiplication algorithm. What is multiplication algorithm and how implemented for signed magnitude data draw flowchart. See here, draw flowchart for multiplication operation. Multiplication means you need to flowchart. Multiplication means you need to draw, now which I am going to explain now. And part A is hardware implementation for signed magnitude addition. Addition means plus, addition, and subtraction minus, and explain flowchart for hardware implementation. This video already shooted and that is also very tough one and I explained very simply and clearly. Now this also I will explain you very simply and very clearly. Watch till the end, you can understand very easily. I will show you, right? Wait a moment, I will show you that video also which I have shooted. See, this is that video and see, this is the poster of that video, addition and subtraction. In that topic, addition and subtraction is in one flow chart only, but that is very big flow chart that takes so much time and I explained clearly and very simply. That is also very important. After these two, one question is compulsory in your exam. See that, watch this.
Second chapter is computer arithmetics. Arithmetics means we know from our elementary school, addition, subtraction, multiplication, division and all. Basic thing. Addition operation this side, subtraction operation this side and addition operation this side will be done. Before that, I will tell you some basic things. Here the basic thing is, show me this. Negative fixed point number, any number, negative fixed point number can be replaced.
See, there I have explained very clearly and simply, and watch till the end. I will put this video at the end of my card and in my playlist also I will provide you. Now we are going to see multiplication algorithm. This is also very important and it seems to be tough, but I will make it very clear to you. See here, while doing pen and paper it is very easy. For example, you are doing 6 into 5, 30, we will get 30. This we know from our elementary school, but inside computer how it will be done, right? I will show you with another marker. 6 will be changed into binary and 5 will be changed into binary and that will be multiplied, right, inside the computer. For example, see here, he has taken 23 into 19. We are doing 23 into 19. 23 will be changed into binary 10111 and 19 will be changed into binary 10011. So how we'll get from decimal number? This is basically decimal number, base 10, radix 10. So that should be changed into binary inside computer, then it will be performed multiplication operation. So right, very simple. For example, I will show you in my previous video also I have shown. If you are watching this only first time, I will show you here. 23 binary means 2, we need to divide with 2. 2 11 ja 22, remainder 1. 2 5 ja 10, remainder is 1. 2 2 ja 4, remainder is 1. 2 1 ja 2, remainder is 0. We need to take bottom to top values 1 0. See the cursor, 1 0 1 1 1, 1 0 1 1 1, base 2. This is the equivalent of 23. See here, 1 0 1 1 1. Similarly, 19 also change it into binary, same like this. So then we need to do multiplication operation. How? 1 into 1, see here, this we know, For example, here I will show you how we will do from our elementary school. Right, 19 3 ja 21, 19 2 ja 1 3 ja 3, 1 2 ja 2, 1 1 3 4, right, 7 27, right, 4 3 7, that we got, right. From our elementary school we did this we know very well, but how it will be done inside the computer, now we are going to see. 23 will be changed into binary, 19 will be changed into binary. So right here 1 1 ja 1, I will show you. 1 1 ja 1, 1 1 ja 1, this all will be here, and we need to shift a bit when you are doing this one, and we need to shift one more bit, 0. See here 1, this will we will get, and this will be put in a register. I will show you very clearly. And next we will do with this, and this will be given, and I will mark it with red. Plus we need to shift right side, and 0, all zeros will come. We need to shift 2 bits, and next 0 we need to shift 3 bits, then 1 next bit, then we need to add whole information, then we will get the answer. See here, we will add everything and we will get the 437 is the answer. This we will know here by doing this, right. But how it will be done inside computer with a flow chart, we need to explain. That's what we are going to do now. See this, I have cross checked here 1 4, this we got the product. Here the thing is, multiplicand in B register he has taken the 23. For example, multiplier Q register we have taken a value 19. It may be 19 or any other value. Here we have taken the example 23 and 19. See here, the thing we need to consider here is, right, I will explain. Multiplication of two fixed point binary numbers in signed magnitude representation. This is signed magnitude representation is done with paper and pen. This will be very easy by process of shift and add operation. See, this will be shifted and finally it is added. By doing this two operation, multiplication operation is done. Operation sequentially. Sequentially means successively, sequentially until this last one is over. This should be repeated. If you have 1 2 3 4 5, we need to get 1 2 3 4 5, then it should be closed, and we need to add this whole and we will get the result. That's what we are going to do in the flowchart. If you know these basic things, this will be very simple, then the flowchart will be very easy. So this seems to be tough for the students and some of the faculty, but if you know these basics, then this will be easy. Now we will compare with the flowchart and the basic things. Now it will be very easy. I will explain you very clearly and very simply. See here, flowchart for multiplication. See the cursor. Flowchart for multiplication algorithm or operation is the title of the diagram. You also draw like this border line, so that you will get full marks. Draw neatly like which I have drawn. I will put, see, title of the diagram here with two border lines, right. Then you will get full marks. Okay, now I will explain you. See the cursor here and the cursor, multiplication operation, right, multiplication operation. Here multiplicand in B, multiplier in Q, right, B and Q. Now we are doing operation B and Q, right, very simple. B into Q we are doing, right, B into, very simple and easy. I will explain you. A suffix S means A sign value. That final result will be in AQ. See here, the final result, end product will be in AQ. It means that AQ is equal to B into Q. That's what we are doing. B is a register, Q is a register. That will be stored in AQ register. So that is the product value, right. I will write this side if you want. Very simple. I will explain you very simply and clearly. See here, AQ. AQ is equal to B into Q. That's what we need to do. Right here, multiplicand in B, multiplier in Q. Right. Up to this over A suffix S means A's sign value. Sign value. A register values. For example, 23 is there. If it is plus, A suffix S is plus. If it is minus, A suffix S is negative. That is equal to Q suffix S. This is exclusive OR gate. B suffix S. B's registers sign value and Q register sign value. B and Q. See, B's register sign value and Q's register sign value. This plus symbol here means, I will zoom it and show you. This means exclusive OR gate. See here, this means exclusive OR gate, right? XOR gate. With that, we will get the A suffix S sign value, and Q suffix S sign value also will get like that only. Then A is one more register that is cleared to 0 first initially. Q is other register. With a pencil I wrote here. See, explanation part I wrote with pencil. You also write neatly the diagram. If you practice while watching this video, watch with earphones and practice in the rough notes 2 times, 3 times the diagram, and write these points one time in the exam clearly, so that you will get full marks. Register is E is clear to 0, and here register A is clear to 0. Now SC means a sequence counter. See here, I wrote here sequence counter. Here I wrote sequence counter, right? That initially, that is n minus 1 because magnitude value, first value will be n, starting value will be sign value. Those the remaining values will be magnitude values. So excluding removing the sign value, the remaining values will be taken n minus 1. For example, plus means 0, here 0. Then very simple, the remaining magnitude value means n minus 1 bit values. For example, you have 4-bit register, so right, first one will be sign value. If it is plus 4, so 0. Then remaining value we need to take 1 2 4 1 0 0, right? 1 2 4, this will be the value. So this is the sign value, and the remaining 3 values he has taken n minus 1. So if it is 8-bit register, 7 bits he will be taking in sequence counter, right? Initially this was that. See here, magnitude, register A is clear to 0. With pencil I explained. N is the number of bits, total number of bits, this one. So very simple. If you understand that, and with you compare the above diagram, it will be very easy with this, with the above diagram. See the cursor. Right now, if Qn is a number of bits, lowercase bits, for example these bits, if it is 1, here if it is 1, this should be added. 1 0 only we will having in the binary multiplication or addition subtraction. We will having ones and zeros only inside computer, inside motherboard and register. Actually we will take operands values from the memory into the register, into BQ register, and we will do the operation, right? So here Q suffix n means number of bits in the Q register is equal to 1. That is lower order bit. Lower order bit means this one. See here, this one and this one. Here 1 1 1. If it is 1 1, this should be added, right? That's what here is telling. Very simple. If it is 0, right? If it is 0, it means that when it is 0, right, this will be shifted right, right? Shifted right. It will be shifted right. I'll remove this. See here, this will be shifted right. So that if you know these basic things, and this diagram will be very easy. When it is 0, it will be shifted right, and sequence counter is reduced to 1, right? Sequence counter is reduced to 1, right? And if it is 1, it will be added. EA is one more register, A plus B will be added. So see this, here it will be added, right? Very simple. Then sequence counter is reduced to 1, and it will be entered into here. When sequence counter is completed, there this process stops when sequence counter is 0. When sequence counter is not equal to 0, it means that it will be done in the next line. When one more shift will be done and one more addition or subtraction will be done. If it is not equal to 0, it will be going back. See here, with other color I will show you. See, if it is not equal to 0 sequence counter, it will be going back to here, again here. And if it is 1, it will be added. If it is 0, it will be shifted. And sequence counter is reduced to 1. It will be reduced to 1 till it equal to 0. If it is not equal to 0, again it will going back. Right? With the diagram, we can understand this. See here. 1 2 3 4 5. Here sequence counter are 5, right? Very simple. 1 2 3 4 5. Here 1 2 3 4 5. 5 times we need to do these operations, and 5 times we need to shift also. We need to shift operations 1 2 3 4 times. Then we need to add total answer. When the sequence counter completes, we need to get back out of the loop. Right here, if condition, this one, this flow chart is a decision. Diamond shape will be decision, and it has two navigations. When it is 0 means this will be stopped. Sequence counter is 0, that will be stopped, and the end value will be product is in QA, right? AQ, very simple. QA AQ register. Here shift to right, EAQ is one more register, that will be shifted to right. See here, this will be shifted to right, this will be shifted to right, this will be shifted, this will be shifted, like that all operation will be done. So at the end the multiplication result will be in AQ, right? That's what we said in the starting. AQ B into Q transfers AQ. B register value, B is a multiplicand and Q is a multiplier, that will be shifted into AQ register by doing this many operations. Here the sign value will be decided. Here A is clear to 0, E register is clear to 0, sequence counter is n minus 1. N minus 1 because the starting bit will be sign bit, whether it is addition plus positive or negative. For positive 0 will be there, for negative 1 will be there. Remaining value n minus 1 out of n bits, 4-bit register or 8-bit register, right? Sequence counter will be n minus 1. In Qn will be lower bit order, means here in the diagram. See above the equation, you can see the above calculation. This is the lower bit order. If it is 1, it will be added. If it is 0, it will be shifted to right side. Right? See this plus marks with red. It will be shifted. It is shifted 1. It is shifted 2. It is shifted 3 bits. It is shifted 4 bits. Because sequence counter is 5, it will be ended here and it will be added finally. So right. See here. Shift SHR means SHIFT, shift. R means right side, shift right. EQA is one more register. With pencil I explained you. Sequence counter is always reduced to 1. When it is not equal to 1, it will be going back. And again same thing, when it is 1, it will be added here. This is one more register, just like temporary register. AB will be added. If it is 0, it will be shifted to right, and the sequence counter will be reduced 1 till it is equal to 0. It will be reduced. When it is equal to 0, we will get the answer in see here, end product is in AQ. Very simple, end product is in AQ. See this diagram completely and rewind it if you don't understand, and pause this and note the points. You can understand very clearly. See here, the key point here is shift and add will be done here. So if you know the basic things, that's why I told you watch till the end. I will explain you clearly. If you know this basic things, basic calculation, with this algorithm was explained. with the flowchart multiplication algorithm. Very simple and very easy and very important. This question will be compulsory in the question paper. These are addition and subtraction algorithm. Out of these two, one question is very much important, right? All the best for your exam, and see this and pause the video and note the points, right? All the best for the exam.